Okay, this is a third video in our Theorem of Thales, the Proportionality chapter 11, and I think it will be a fairly short video. So let's come back to the concept of agrandissement réduction par centre d'homothétie. So here we have an example of a triangle ABC which I have used a centre d'homothétie O, and I have made an image on this side with k est égal à -1. You can also say k est égal à 1 because the OA est égal à OA prime, OC est égal à OC prime, and OB est égal à OB prime. So it's the same size, only it is mirrored, or basically you can also consider it's a l'image par symétrie par rapport à point O. Okay, so this is, of course, we have already done this. I'm just revising certain things. You'll see why in a moment. And here I've taken the same thing but on the same side. On we have again a triangle ABC, and we have a image A prime, B prime, C prime, where I have taken k est égal à 2, OC prime sur OC est égal à 2. You can see that because this and this are equal. Similarly, OB prime sur OB est égal à 2, et de même OA prime sur OA est égal à 2. So this is the way you have to do an agrandissement using a centre d'homothétie. This is all this you already know. But now I ask a question: what if the center of homothétie was one of the sommets of the triangles of the triangle? So instead of taking O there, what if I took, let me get this in focus. Yeah. Well, instead of taking O there, what if I took O on point A itself? So let's go there. By the way, sommet in English is called apex or vertex. So this is A prime is an apex of the triangle A prime, B prime, C prime. Okay, or vertex. You can use either word if you're doing it in English. Okay. So now let's take this. So we have a triangle ABC. Let me use this hand. We have a triangle ABC, and we make point A our point O, and we take a agrandissement from this point, and we get A prime, B prime, C prime. So in this case, very clearly, O, A and A prime are the same point there, and using the K, we get OB prime. We can draw OC prime and then join B prime and C prime to get the bigger triangle O C A prime, C prime, B prime, or A, which is an enlargement of A C B. Okay. Now what does this triangle look like to you? What does this figure look like to you? Of course, it is the figure of the Theorem of Thales of Proportionality. And if we look at it, A C prime sur AC est égal à, this is from Theorem de Thales, OB prime sur OB et AC, sorry, no, I should have written AB prime, and this is, sorry, that's a mistake, B prime, C prime sur base A. Okay, sorry about that. So now this is, anyway, if you omit this last ratio, base A prime, B prime, C prime sur base A, what you get is these two ratios are basically what is K, because A prime, C prime divided by AC is K. But here, instead of writing A prime, C prime, I am writing AC prime because this is the standard, because A and A prime are the same point. So instead of using A prime, I am using A here. So this bit, this whole thing is the Theorem of Thales of Proportionality, also this, but in this particular case we are interested in this. So, this links our agrandissement et réduction avec un centre d'homothétie to Theorem de Thales. This is a useful concept. In some of the problems they will mix these two different concepts and ask you questions. Okay. So now we move on to what is known as the reciprocal. We had already seen this. Where had we seen this? Let me find it. Yes, if it was the corollary, if two lines BM and CN intersect at point A, any one of these three drawings, and AM over AB is not equal to AN over AC, then MN and BC are not parallel. So the reciprocal of the Theorem of Thales states that if this ratio is true, if AM sur AB does equal AN over AC, then MN and BC are parallel. So here is, see, here what is the hypothesis? If two lines BM and CN intersecting at point A are intersected by two parallel lines. So here the hypothesis is that base A and MN are parallel. Here the hypothesis is that this ratio is true. So then the consequence is that these two lines are parallel. In more formal terms, this is the way it is written. If AM over AB is equal to AN over AC in the case of lines BM and CN intersecting at point A, that is AM and BM and CN intersecting at point A, this is the drawing, and if points ABM and ACN are in the same order, then BC is parallel to MN. So here they say that if this ratio, if AB over AM is equal to AC over AN, then these two lines are, I was focusing. What it says is if AB over AM is equal to AC over AN, then these two lines are parallel. And they work whatever order you put A and B in, as long as you use the same corresponding order for A and C. So here in this second example, here we have moved B in between A and M. Here B was outside A and M, it was outside here. Here we put it in between. But if we follow the same order on this side also, then again AB over AM is equal to AC over AN, then these two lines are parallel. And the third example is when you go opposite sides of the point of intersection. If AM over AB is equal to AN over AC, then these two lines, MN and BC, are parallel. So what happens if this part of the condition is satisfied, but not this? If the points are not in the same order, then you will see that you have to have this condition as well as this condition both satisfied before this is true. So in these three examples, both this condition as well as this condition of order of points are satisfied. So in all of these three examples, MN is parallel to BC. Now let's take another example where this doesn't actually work. So here let's take this example, and I've actually drawn it quite correctly. This is point A. A to M is one diagonal on my paper. So A to M and A to B is two diagonals of these tiny squares that are there on my paper. So AM over AB is equal to AN over AC is equal to 0.5. AM is half of AB. But in this case, I draw on NC, I put N on one side of A and A on the other side of, C on the other side of A. And what do I get? I get AN. Again, AN is half of AC, just like AM is half of AB. But then, of course, when I join the lines, I'll get NM going this way, BC going this way. They're far from parallel. they're indeed intersecting just here. So in this case, MN is not parallel to BC, even though this condition is satisfied, but this condition of the order of lines is not satisfied, therefore this is wrong. So here is the end of this lesson part of this video. Now I will give you the homework, and the homework is graded. So I will ask you to do some very simple problems. You can go through them very fast. So here we are. You will do. So now for the homework part, this is a graded assignment. We will do problem number 5. So I will focus on 5 for a little while. Then you will do problem number 6. Okay, here the rapport is negative because it's on opposite sides of point L. Then you will do problem number 7. These will each take about 2-3 minutes. So problem number 5, problem number 6, problem number 7. Of course you have to pause this video. Then you have problem number 8, problem number 9, and these are the 5 problems I want you to do. Okay, you should have no problem in doing any one of these because these are very simple, and they just want you to, these problems will make sure that you are aware of the concepts and the terminology involved. Okay, we stop here.